Look up at the night sky. Right now, our universe is bursting with light and energy. We live in the stelliferous era, the age of stars. The cosmos has been expanding and evolving for 13.8 billion years. It feels permanent, but scientifically speaking, this bright phase is just a fleeting cosmic spark. The laws of thermodynamics dictate a chilling ultimate fate: the heat death. A time when all energy is evenly distributed and nothing new can ever happen. Fast forward roughly 100 trillion years from now. The very last stars, the dim and incredibly long-lived red dwarfs, will finally exhaust their nuclear fuel. Welcome to the Degenerate Era. It is incredibly cold, pitch black, and completely silent. Our cosmic campfire has permanently and irreversibly burned itself completely out. All that remains are stellar remnants, freezing white dwarfs, silent neutron stars, and massive black holes roaming through an ever-expanding, infinitely freezing cosmic empty void. For ordinary life, this is the absolute end. Without starlight, planets freeze solid, and natural biological processes become mathematically and physically impossible to ever sustain. But what if intelligence survives? A hyper-advanced civilization might not accept this dark fate peacefully. They would meticulously prepare for the long, infinite cosmic winter. Enter the concept of a Type 3 civilization on the Kardashev scale. A society so technologically advanced, they command the immense energy of an entire galaxy. Even with godlike technology, they face the ultimate cosmic energy crisis. You cannot create new energy from nothing. You can only patiently harvest what is left. And in the Degenerate Era, the only significant sources of stored energy left in the cosmos are the most extreme objects governed by general relativity: supermassive black holes. Usually thought of as destructive cosmic vacuum cleaners, to a desperate Type 3 civilization, they are the ultimate, perfect, long-lasting cosmic batteries. A black hole does not just have immense mass. Many of them spin at relativistic speeds, literally dragging the very fabric of space-time around with them. In 1969, physicist Roger Penrose proved mathematically that this immense rotational energy is not locked away forever. It can actually be efficiently and systematically stolen. By dropping engineered objects into a specific region just outside the event horizon, a civilization could theoretically power their empire for billions or trillions of years. This specific region outside a spinning black hole is called the ergosphere. It is a boundary where the normal rules of physics become incredibly strange. Here, the black hole spins so fiercely, it literally drags the fabric of space-time with it. Within this zone, absolutely nothing can stand still. To harvest this, you use the Penrose process. You precisely maneuver an object deep into the ergosphere and then deliberately split it into two halves. One half is pushed past the event horizon, effectively acting as negative energy, while the second half is forcefully shot back out into space. The escaping piece literally steals rotational energy from the black hole. Using this method, you can extract up to 29% of the black hole's entire mass. To a surviving Type 3 civilization, this isn't just a clever physics trick. It is the ultimate foundation for their cosmic survival. They would construct massive orbital megastructures, known as Penrose Spheres, skimming the very edges of the ergosphere to continuously harvest this rotational momentum. These colossal generators would beam pure, endless energy to their remaining colonies, keeping their society brightly lit against the freezing, eternal dark. But what if they needed more? What if they wanted exponential, immense power? Enter the theoretical concept of the ultimate energy amplifier. Proposed by physicists William Press and Saul Teukolsky in 1972, it relies on a mind-bending phenomenon called superradiant scattering. Instead of dropping physical objects, you shoot a beam of electromagnetic radiation, like a photon of light, directly into the swirling ergosphere. But first, you must completely enclose the supermassive black hole in a colossal, perfectly reflective spherical mirror, trapping everything inside. The light enters the ergosphere, gains energy from the black hole's rotation, and bounces off the interior mirror shell back inside. Bounce after bounce, the light wave gets continuously amplified, gathering an unimaginable, trapped, glowing tidal wave of pure radiant energy. By carefully opening a small window in the mirror, the civilization releases a highly concentrated beam of power, sustaining them for eons against the void. For billions and trillions of years, the civilization thrives inside their mirrored oasis. But in this universe, absolutely nothing is truly eternal. To understand their next existential threat, we must zoom in past the massive scales of astrophysics down to the microscopic quantum level near the event horizon. Empty space is never truly empty. According to quantum mechanics, pairs of virtual particles are constantly popping into existence and immediately destroying each other. But in 1974, Stephen Hawking realized that if this happens exactly on the edge of a black hole, one particle might fall in while the other escapes. This escaping light is called Hawking radiation. Because the black hole provides the energy for the escapee, the black hole very slowly loses mass. It is evaporating. The clock is ticking, but it is the slowest clock imaginable. For a supermassive black hole, complete evaporation takes roughly 10 to the power of 100 years. A Google years. Eventually, the Type 3 civilization notices the change. The immense rotation of their captured black hole slows down. The energy output inevitably drops. As the black hole loses mass, its evaporation speeds up. It shrinks, gets exponentially hotter, and radiates its remaining energy faster and faster into the void. In its final moments, the black hole releases its remaining mass in a final, brilliant flash of pure cosmic light. And then, it is simply gone. The colossal Penrose Spheres are now useless, empty shells. The civilization's ultimate battery is dead. But incredibly, it gets even worse. The very materials their machines and bodies are built from might not be permanent. We enter the realm of a terrifying hypothesis: proton decay. Protons are the heavy building blocks of all atoms. For a long time, physics assumed they were perfectly stable. But many grand unified theories suggest otherwise. Data from the Super Kamiokande Observatory sets the minimum half-life of a proton at 10 to the power of 34 years. A mind-bogglingly long time, but not infinite. If true, it means that deep into the dark era, the solid metal of the dead megastructures will literally dissolve into a faint mist of stray light and elementary particles. No engineering, no matter how advanced, can stop the very atoms of their bodies and tools from quietly fading away into the endless night. With protons dissolved, the physical universe of planets, stars, and megastructures is permanently over. All that remains is a sparse soup of stray photons and electrons. This brings us to the ultimate endgame of thermodynamics: maximum entropy. A state where all energy is perfectly and uniformly distributed across the entire cosmos. To do any kind of work, or to power a machine, you need a difference in temperature. Energy must flow from a hot source to a cold sink. But in this final era, there are no hotspots left anywhere. Everything is the exact same, freezing temperature. Without a gradient, nothing can ever happen. The background temperature of the universe will plunge to a tiny fraction of a degree above absolute zero. A cold so profound, it stops all atomic vibration. Without change, without any physical events occurring, the very concept of time begins to lose its meaning. The arrow of time requires progression, but here, everything is static. To make matters more isolating, dark energy continues to relentlessly expand the fabric of space. The remaining photons are pushed infinitely far apart from each other. Eventually, the universe expands so rapidly that a photon emitted from one point will never ever be able to reach another particle. Ultimate cosmic isolation. It sounds terrifying, but from a thermodynamic perspective, it is profoundly peaceful. The universe isn't violently destroyed. It simply goes to sleep. This brings us back to our current reality, the stelliferous era, the age of stars, galaxies, warmth, and the chaotic beauty of life. Compared to the trillions upon trillions of years of darkness ahead, our bright, energetic era is nothing but a fleeting, microscopic spark in the cosmic timeline. We happen to exist in the exact sliver of time where the universe is complex enough to support chemistry, biology, and conscious thought. We might not be a Type 3 civilization capable of harvesting black holes to survive the end of time. But maybe we don't need to be. Because right now, we are the universe experiencing itself. We are here to witness the light before the long, beautiful silence begins. Wait, Before we completely close the book on the universe, there is one massive, mind-bending scientific loophole we have to explore. Everything we just discussed assumes that protons eventually decay. But what if they don't? What if fundamental matter is truly, perfectly stable? If matter survives, the dark era will be interrupted by the strangest objects in physics. Let's rewind to the frozen white dwarfs. Over trillions of years, they cool into black dwarfs. They emit absolutely zero light or heat. They are effectively giant, dead diamonds. Inside, crushing gravity pushes atoms together, but they are frozen. However, at the microscopic level, the universe allows a mathematical cheat code. It is called quantum tunneling. Subatomic particles can occasionally bypass solid barriers, teleporting through them due to the probabilistic nature of quantum mechanics. Because of this, even at absolute zero, atoms inside the black dwarf will very, very slowly fuse together. This is called pycnonuclear fusion. This process is agonizingly slow. It might take millions of years for just a single microscopic fusion event to occur, but over unimaginable timescales, 10 to the power of 1100 years, this slow quantum fusion completely transforms the star's internal chemistry. It becomes an iron star, a bizarre, hyperdense sphere of perfectly stable iron floating in the utter darkness. It cannot fuse anymore. In 2020, theoretical physicist Matt Kaplan published a paper showing that this slow fusion eats away the star's internal quantum pressure. Without that electron pressure holding it up, the crushing weight of gravity finally wins. The iron star's core violently condenses. This triggers a black dwarf supernova, a spectacular, brilliant cosmic burst of energy illuminating the pitch-black universe one last time. These are the absolute final fireworks of the cosmos. They happen so far in the future that even supermassive black holes have already evaporated. If our Type 3 civilization somehow preserved their digital consciousness in the dark, they would witness these isolated flashes, gathering the universe's absolute final drops of warmth. If physical matter inevitably fails, is there any other way for a Type 3 civilization to survive? The answer might lie in the fundamental nature of information. In modern physics, the universe isn't just made of particles and fields. At its deepest level, it is made of pure mathematical information. This realization led to the famous black hole information paradox. When a black hole evaporates, does the information of the things it swallowed disappear forever? Many physicists solve this with the holographic principle. It suggests our three-dimensional reality is actually a projection of information encoded on a two-dimensional surface. If reality is fundamentally just information processing, then our hyper-advanced civilization doesn't need physical bodies to survive. They just need a computer. In 2003, philosopher Nick Bostrom formalized the simulation hypothesis.
Each bubble represents
a Type 3 civilization could theoretically simulate an entire universe inside a machine. Before the stars completely die, they could build a Matryoshka brain, a colossal computational megastructure that harvests star energy specifically to run simulated realities. They would upload their entire consciousness, their culture, and their history into this digital paradise, leaving their biological bodies behind forever. But there is a fatal flaw. Computers require energy, and computing generates heat. In the dark era, energy is the one thing you cannot afford to waste. To survive, they must use reversible computing. Based on Landauer's principle, if a computer never permanently deletes information, it theoretically generates zero heat. By dropping the computer's temperature close to absolute zero and running the simulation incredibly slowly, they stretch their final energy reserves to near infinity. One subjective day inside their digital paradise might take billions of years in physical reality. But waiting this long introduces the most terrifying paradox in physics. Named after Ludwig Boltzmann, statistical mechanics states that if you wait long enough in a chaotic system, absolutely any configuration of particles will randomly occur. Given infinite time in the dark void, quantum fluctuations will randomly assemble particles into a fully functional thinking entity. A Boltzmann brain. This brain exists for a fraction of a second, but with completely false memories of an entire life. Statistically, it is infinitely more likely that you are a Boltzmann brain right now. But let's step back from the existential dread of Boltzmann brains and simulations. Let's assume physical reality is exactly what it appears to be. We are back in the present day. The universe is incredibly vast, stretching out to an observable diameter of 93 billion light-years. But because the universe is expanding faster than the speed of light, there are galaxies we will never, ever be able to reach, no matter our technology. So, if a civilization wants to harvest the universe before the heat death, they cannot wait. They must expand aggressively right now. They would likely use von Neumann probes. These are theoretical, self-replicating robotic spacecraft designed to explore and colonize autonomously. A single probe flies to a dead asteroid, uses the raw materials to build a perfect copy of itself, and then both probes fly off to new targets. 1 becomes 2, 2 become 4. Within just a few million years, a single civilization could theoretically touch every single star in the Milky Way. These machines would quietly begin dismantling dead planets and enclosing stars in Dyson spheres, hoarding energy for the long, dark eras to come. But look up. Do you see any stars suddenly winking out? Do you see galaxy-spanning megastructures? No. The sky looks natural and untouched. This profound silence is the Fermi paradox. If surviving the end of time requires aggressive cosmic engineering, why haven't we seen anyone doing it? Maybe the engineering challenges of surviving the heat death are physically impossible. Or maybe civilizations inherently self-destruct before they reach Type 3 status. But there is a third, incredibly beautiful possibility. Maybe we are simply the very first ones here, the early arrivals to the cosmos. The universe is barely 14 billion years old. Compared to the unimaginably vast timeline of the heat death, the universe has essentially just been born. If we are the first, then the responsibility of building those megastructures, of surviving the dark, falls entirely on us. We have trillions of years to prepare. The cosmic winter is coming, but humanity has plenty of time to learn how to build a fire. To even have a chance against the ultimate freezing fate of the heat death, humanity must first survive its own technological adolescence. We are currently a Type 0 civilization. Our first monumental step is reaching Type 1 status, harmoniously harnessing all the available energy of our home planet without disrupting its natural biosphere. Then we ascend to Type 2, capturing the entire vast energy output of our Sun using a massive, brilliant Dyson swarm, securing our survival for billions of years. Only then can we safely spread across the Milky Way, spending millions of years evolving into the godlike engineers of a true Type 3 civilization. It seems like an impossible mountain to climb. But physics gives us the greatest gift of all: time. We have so much time. Our own sun has another 5 billion years of fuel. The smallest red dwarf stars will continue to burn brightly for trillions of years after that. The dark era of black holes and freezing voids is so unimaginably far away, it is mathematically and physically impossible for the human brain to truly comprehend. To put it in perspective, if the entire lifespan of the universe, until the very last black hole evaporates, was a physical timeline stretching all the way from Earth to the edge of the observable universe, the era of stars, the era of life, and everything we have ever known or will ever know wouldn't even equal the width of a single atom on that line. We live inside that single beautiful atom of time. The universe will spend 99.9, repeating, % of its existence in total darkness. But we are the lucky ones. We get to witness the light. We get to understand the physics of the stars, the black holes, and the fate of reality itself. So while the ultimate heat death might be the inescapable, freezing destiny of the cosmos, right now the universe is warm, it is bright, and it is beautifully alive. We are the universe's way of thinking, exploring, and fighting back against the dark. And that makes our brief moment in the sun incredibly special. Thanks for exploring the end of time with us. If you want to keep diving into the deepest mysteries of astrophysics, make sure to hit that subscribe button. Until next time, keep looking up. And as always, stay curious.